Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about the composition of atmosphere. So, what are all the various gases which have been present in the atmosphere and what is their role in the atmosphere and then in the earth's surface. So, today we will be discussing about the lecture on vertical structure and thermal layers of the atmosphere. So, what all the contents we are going to discuss in this lecture are the atmospheric divisions, major thermal layers, structure of atmosphere, temperature variation with the altitude concept, significance of atmospheric layers. Atmosphere, that is, it is a mixture of gases that surrounds the earth's surface. It extends up to 1000 kilometer. The present of atmosphere is sourced from the earth's interior. So, in the evolution of atmosphere, so what we have discussed, from the interior of the earth, the gases and other particles which have been ejected out by which source, that is volcanic eruption. So, by the volcanic eruption, all the gases or interior part of the earth, the components have been evolved and it have been erupted and it forms as the atmosphere. The layered structure based on the changes in the temperature with the altitude and composition. Atmospheric divisions. The atmospheric divisions based on thermal characteristics, that is the change in the temperature with altitudes. So, we will be discussing in each and every layers how there is a deviation or difference in the temperature in the increasing heights. Next, the chemical composition. So, what are all the chemical composition of the atmosphere? In the previous lecture, we have discussed about what are all the two major that is chemical layers, that is homogeneous in the lower layer and heterogeneous in the upper layer, and then the density and pressure. So, both decreases with the increasing heights. Next is the functionality. Each and every layer of the atmosphere has its own functionality. So, for example, if it is going to be ozone layer, the ozone which have the importance of observing the ultraviolet radiation, and then the next layer, the important function is ionosphere. It has the atom and energy particles. So, that we will be discussing in the upcoming slides. Structure of atmosphere have been divided into 5 major layers based on the temperature variation. The temperature alters between the decreasing and increasing altitudes. Each layer plays a distinct climatic and protective roles. So, about 50% of the atmosphere which will be in the altitude of what? That is 5.6 kilometers. And 97% of the atmosphere is confined to which height? That is only 29 kilometers. In the 29 kilometers, all the entire composition of atmospheric action also takes place in this 29 kilometers. So, this 29 kilometers is the most important and plays a vital role in the atmospheric and earth interference. Next, the major thermal layers of the atmosphere. The atmosphere have been categorized into 5 major layers, that is, the first and foremost layer is the troposphere with the height of 0 to 18 kilometer, and the next one is the stratosphere with the height ranging from 18 to 50 kilometers. Next is the mesosphere, that is 50 to 85 kilometers. Next is a thermosphere, that is 85 to 600 kilometers. Next layer, that is outermost layer of the atmosphere, is exosphere, which ranges from 600 kilometers up to 10,000 kilometers. So, the first and foremost layer, that is the lower layer of atmosphere, is troposphere. That is, it is also known as weather layer. So, why it is called as weather layer? All the weather phenomena takes place in this particular lower layer of the atmosphere. This troposphere is also known as zone or region of mixing or changing sphere or turbulent zone or convective layer. So, these are all the names in which we call as a troposphere. So, because all these activities have been taken place in this troposphere. It extends from 8 kilometers at the poles and 18 kilometers at the equator. It is due to convection and heating difference. So, this is the major cause of difference in the equatorial region as well as in the polar region. It is considered as one of the most important layer for the weather and life forms of the Earth's surface. It consists of 75% of total atmospheric mass and almost all the water vapor. That is, it is rich in the dust particles, aerosols and greenhouse gases. So, in the previous lecture, we have discussed that the troposphere which consists of dust particles, aerosols and greenhouse gases, that can be recalled here. The next is the high air pressure and density, which will be near in the Earth's surface due to the gravitational pull. Nearly 50% of the effective atmosphere lies below the height of 5.6 kilometer. The maximum at equator and deeper in the tropics up to 20 kilometers. So, here is a catch that the maximum is in the equator and deeper in the what? Tropical region, tropics up to 20 kilometer, and shallower in which region? That is polar region with 7 kilometers in summer and distinct winter. So, this is a most important point to note here. And in India, the height of the troposphere is what? That is 16 kilometers. That is, the maximum thickness at the equator is mainly due to, so we have discussed that thickness of the troposphere is in the equator. Why this thickness in the equator? It is because of the following reasons: high insolation and strong convection currents. So, in the equatorial region, we know that there is a direct sun rays. So, because of that high insolation in that equatorial region, and because of the heat, what happened? The strong convection current which occurs in this equatorial region. Next one is air is less dense in equator. This is also one of the important factor. The pole exert more gravitational pull than the what? Equator. So, it is also one of the reason that in the pole the thickness is less and in the equator the thickness is high. And the next one is centrifugal force, and then if we call it as a centrifugal force as well as what is the another force common due to the Earth's rotation, that is Coriolis force. The centrifugal force, Coriolis force, due to which the rotation, that is the rotation of Earth, its maximum in where? That is in the equatorial region. It is also one of the factor which contributes for this thickness in equator. The chemical composition of troposphere, that is high quantity of water vapor variation which will be found in the equator. This is one of the major factor, and the temperature of troposphere, that is ELR, that is environmental lapse rate or normal lapse rate. So, due to these reasons, troposphere is thick in the equatorial region. It is heated through the terrestrial radiation. So, as this troposphere is the lowermost layer of the atmosphere, the terrestrial radiation is the most important factor which heats the troposphere. The lower layer which is warmer than the upper layer. So, we know that if it is going to be near, the terrestrial radiation will be high, and if it is a higher altitude, the terrestrial radiation will be comparatively less to the lower regions. Exhibits the steady fall in temperature with altitude. So, in this diagram, so we have the minus temperature in this region and plus temperature in this region. So, in the troposphere, while considering it, the temperature is what? Decreasing. So, the temperature is decreasing here in the increasing altitudes. This is mainly called as what? The environmental lapse rate, that is 6.5 degrees Celsius per kilometer. The solar heating occurs from the Earth's surface upward. Solar heating is from the Earth, not from the upward. It is not from the upward, it is from the Earth's surface. So, this is also one of the reason. This temperature decrease drives the air circulation and convection currents in this particular troposphere layer. all the weather events as discussed earlier, all the weather events, that is formation of clouds, formation of rainfall, and formation of storm, fog, wind activities, and then cyclone formation and snowfall, all these formation occurs in this troposphere. And condensation and precipitation also takes in this layer, that is in the troposphere. It plays a central role in the climate control and it also supports the entire ecosystem. Then after the troposphere, we have another important boundary, that is above the troposphere there is a tropopause. The tropopause is marks as a upper boundary for this troposphere. It is also known as a mixing stop. In the name itself we can understand it is a pass. Pass means some stop activities or some constant activity which will be taking place in this region, that is the mixing stops. What mixing stops? The gaseous mixing stops here in this tropopause. It acts as a thermal and dynamic barrier which prevents the mixing of stratosphere. So, it is a barrier for this troposphere as well as the next layer, that is stratosphere. It traps the weather system below, and while jet streams often flow near this tropopause. In this tropopause only what? The jet stream is often flowing in this region. The next layer of the atmosphere is the stratosphere. It is also known as the ozone layer. It extends about 18 kilometer to 50 kilometer altitudes, and it is characterized by dry, stable air and very low water vapor content. It is devoid of major weather event. We have discussed that in the troposphere all the major weather event occurs in the troposphere, but here it is not so. It is devoid of the major weather phenomena. Only the circulation of feeble winds and the presence of rare high clouds, that is nacreous clouds in the polar region. Sometimes it is also called as polar stratospheric clouds. So, this cloud is present in this layer in rare case. Unlike the troposphere, the temperature increase with the altitudes in this layer. So, in the troposphere what we have discussed, there is a decrease of temperature, but in the stratosphere there is a increase of temperature in the increasing altitude. And the heat is mainly due to what? The presence of ozone. So, ozone layer that absorbs the ultraviolet radiation and it have the heat within it and it makes it warmer. The warmer upper levels create a temperature inversion and making a stratosphere calm and stratified. This ozone exists in two zones, that is the tropospheric ozone. It is known as bad ozone, and stratospheric ozone it is called as good ozone. What is good? What is bad? So, if it is going to be bad ozone, it is nearby the earth's surface, that is in the troposphere. So, we know that if it is going to be nearby the earth's surface, all the anthropogenic activities, the human activities which creates the pollution and other important disturbance will be going to which layer? Troposphere. So, because of that, this ozone which is present in troposphere is considered to be bad ozone, and it if it is increase in that ozone content, it will be irritant to the human eyes and it cause a adverse effect in the human being and other biological lives. And then the next is the stratospheric ozone, that is it is a good ozone. So, where the ultraviolet radiation is observed, it gives a positive impact. So, it is called as good ozone layer. The ozone layer is concentrated between 20 to 30 kilometer altitude within the stratosphere. It is also known as ozonosphere. The ozone is 1.5 times dense as the oxygen and it readily dissolves in what? It readily dissolves in water. The ozone absorbs ultraviolet radiation, we know that. So, what type of ultraviolet radiation and what percentage of ultraviolet radiation is received by ozone? That is UVA, that is 5 to 10% UVA is received by this ozone layer, and then 75 to 80% of UVB is observed by the ozone, and 90 to 95% of UVC is received by this ozone. So, by receiving all these rays, UV rays, it is protecting the living organisms on the earth's surface. Any depletion of ozone can lead to what? Increasing UV exposure, and it affects the environmental impacts. The stratosphere consists of smooth turbulent free air. It is ideal for high altitude jet aircraft. So, because of the smoothness of air there in the stratosphere, which is very much supportive for the aircrafts to fly in that particular zone. And planes fly here is to avoid storm and convection current, and it which is present in the troposphere. Troposphere, all these convection current and storms are visible, but here it is very smooth in the stratosphere. So, this is very much supportive for the aircraft to fly in this particular zone. It also reduces the air resistance, which improves the fuel efficiency, it saves the fuel, and also it also controls the speeds of the aircraft. The stratopass is the next one. Here we saw above the troposphere there is a tropopass, and then in the stratosphere we have another pass, that is stratopass. So, here also the pass, something is going to be constant. So, in this stratopass, what is the boundary of it? It is around 50 kilometer altitude. The temperature reaches its maximum at this point before falling to the mesosphere. That is, in this mesosphere, what happens? The temperature will drastically fall. So, here we have the temperature increase. So, it is the midpoint of these two layers. It serves as the transition between a warm stratosphere as well as the cold mesosphere. The mesosphere is the next layer, that is the third layer of the atmosphere. The mesosphere is above the stratosphere. It extends from 50 kilometer to 80 kilometer. The temperature decreases sharply with the altitudes. It reaches minus 90 degrees Celsius. In this region, what happens? These meteors will burn. So, it will disappear. Because of what? Because of the friction with the atmospheric particles. It contains very little ozone and very low density of air. Because of this, there is a drastic decrease in the temperature in this particular mesosphere. Very strange and high latitude clouds called as noctilucent clouds or polar mesospheric clouds sometimes form in this mesosphere near the polar region. So, as we discussed, there is a clouds which is formed in the stratosphere, that is nacreous clouds. Here there is a clouds which is forming in the polar region, that is noctilucent clouds, which is a phenomena takes place in rare case. It is considered the least explored layer because of this extreme cold in nature. It is due to the difficult access of the aircraft and the satellite in this layer. The upper boundary of mesosphere is the mesopass. Again, after tropopass, stratopass, then mesopass. The temperature decreases sharply with the height, making it the coldest layer of the atmosphere. So, how much it is decreased? That is minus 90 degree Celsius near the mesopass. The cooling occurs because there is a very little ozone or little air density to observe the solar radiation. So, that is the main reason for this extreme cold in this particular zone. The air density is extremely low, but still higher in the thermosphere above. The strong wind and atmospheric tide circulates the horizontal around the globe, which is the global atmospheric circulation and energy balance have been contributed because of these phenomena. In the mesosphere, that is the boundary between the mesosphere and the thermosphere is the mesosphere. So, it is the coldest atmospheric layer. It is the zone in which the meteors burn up. This region where the noctilucent clouds forms. The next layer, that is fourth layer of the atmosphere, is the thermosphere. The name thermosphere, we can understand that the thermo means heat. It is also known as hot layer. The layer above the mesosphere is the thermosphere. The height of this thermosphere is 80 km to 700 km. The temperature rises with the height. Mesosphere, the temperature decreases. Here in the thermosphere, the temperature again increases. And in this sphere, what happens? It absorbs the X-rays and it absorbs the UV radiation. It contains the ionosphere that ranges from 80 to 400 kilometers. It is rich in, the name itself implies that, iron and free electrons. The main function of this layer is it supports radio wave transmission, and this layer have the auroras, that means the aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere. Ionosphere. The thermosphere is further bifurcated as ionosphere. It is located roughly 60 km to 1000 km altitude. It consists of ionized gases due to the solar ultraviolet radiation and X-ray radiation. It plays an important role in what? That is radio communication, GPS signals and aurora formation. Ionosphere D layer. So, it has various layers like D layer, E layer and F layer. The first layer is D layer. It is found at the altitude of 60 to 90 kilometers. It is the lowest part of the ionosphere. It has the weakly ionized particles mainly during the daytime. It absorbs low frequency radio waves, causing them which will be fading during daytime. The next one is the ionosphere E layer. It is also known as sporadic E. It is located in the altitude of 90 to 150 km. It is also known as Kenley-Haviside layer. It is moderately ionized. There in that D layer, it is low ionized layer. Here it is moderately ionized layer, formed mainly due to solar UV radiation. It reflects what? Medium frequency radio waves, which aids in the long distance communication during the night time. The next ionosphere layer is F layer. It is also known as Appleton layer. It is divided into F1 and F2 layer. F1 layer extends from 150 to 220 kilometers, present during the daytime, and F2 layer extends from 220 to 800 kilometers, which have the strongest ionized which is present in both day and night time. It reflects the high frequency radio waves, enabling the global radio communication. It supports the satellite communication and the long range broadcasting. The importance of this layer is that it enables the shortwave, ham radio transmissions, influences aurora formation, that is northern and southern lights. It is important for the GPS, satellite navigation and atmospheric studies. Exosphere, the outermost boundary of the atmosphere, the fifth layer of the atmosphere, which extends from 700 km to 1000 km and beyond. It goes to the outer space also. It gradually merges with the outer space. Mainly, it composed of light gases such as hydrogen and helium. The air particles in the that is exosphere extremely sparse comparatively in the lower layer, and almost it is vacuum. That is, the satellite orbits the earth in this layer. So, all the satellite which we are launching now, mostly it will be orbiting in this exosphere. It consists of extremely thin gases, mainly that is hydrogen and helium gases. The exosphere, what is the temperature of it? Exosphere will be very hot. Why it is very hot? And what is the temperature of exosphere? It has a very high temperature, that is beyond 5000 degrees Celsius. It is mainly due to the solar radiation absorption. So, it is nearby the solar, that is sun's action, that is incoming solar radiation. So, because of that it receives the highest incoming solar radiation. Due to that, the temperature is beyond 5000 degrees Celsius. The gas molecules rarely collide with due to what? Very low density. The density is low. Because of that, the collide process is occurring in a rare manner. It acts as a transition zone between the atmosphere and outer space. So, atmosphere and outer space, it is the exosphere is the transition zone. It contains the satellite in low Earth orbit and also some of the space debris. So, we can see the debris also in this region. It also protects from the direct solar wind which impacts some of the extent, and it acts as a boundary from the atmospheric escape. So, what we see in the evolution of atmosphere, hydrogen and helium freely escape to the outer atmosphere, that is outer space. The same thing happened here. The atmospheric escape is happening in this layer. It is the boundary for that particular process, where the light gases like hydrogen and helium can escape to outer space easily. So far we have discussed about various layers of atmosphere, the 5 layers of atmosphere. In each and every layer we have discussed what is the temperature, whether there is an increase or decrease in temperature with the altitude, with the height. But in this slide we will be discussing in detail about what is the temperature variation with the altitude concept. That is, the first and foremost layer, the lower layer is troposphere. In the troposphere, the temperature is decreasing, and then the boundary of the troposphere is the tropopass. So, there is a pass, the constant, and again in the stratosphere what happens? The temperature increases, and in the stratosphere again there is a constant, and it is a boundary between stratosphere as well as the mesosphere, and then again the temperature drastically decreases in the mesosphere. Then there is a constant which occurs here in the mesopass, and then again the temperature drastically increases in the thermosphere. So, there is a increase, decrease, the alternative pattern of the temperature variation in the altitudes. So, this is the main factor. So, in order to remember this one, it will be like a sigma pattern of the temperature variation in the various layers. So, you can remember this sigma sign for this concept. So, overall summary of this entire lecture is the atmosphere have been divided into major 5 layers based on the temperature variation, that is troposphere, stratosphere, mesosphere, thermosphere and exosphere. The temperature decreases in the troposphere and increases in the stratosphere, decreases in the mesosphere and rises in the thermosphere. These layers regulate climate, support weather, protect life forms, harmful radiation and enable the phenomena like auroras and also allow the satellite communication. Hope you understand the various layers of the atmosphere and its uniqueness of the atmosphere, what all the importance of the atmosphere. So, in the upcoming lecture we will be discussing about seasonal variation in the latitudes. Thank you.